Think about the Great Pyramids at Giza, standing tall for millennia, or the incredible aqueducts that brought water to ancient Rome. Consider the stonework of Machu Picchu, fitted together with unbelievable precision. These monuments amaze us, definite proof of the incredible skill of ancient engineers. But how did they build these wonders without cranes, computers, or modern power tools? Figuring out these ancient engineering techniques is a fascinating journey, mixing archaeology, history, science, and even hands-on experiments. So how do we piece together how these ancient builders worked? It's like a giant puzzle, with lots of missing pieces. Our main clues come from the structures themselves. By studying ruins, researchers can see the materials they chose, how they put things together, even the marks left by their tools. Discoveries of old tools, quarries where they got their stone, and the remains of workers' villages add more detail. We also look at ancient texts and pictures. Writings like those from the Roman architect Vitruvius give us priceless information about building principles, materials, and machines they might have used. Sometimes, old carvings, paintings, or mosaics show construction scenes or tools in action. Science plays a big role too. Analyzing materials that have survived, like samples of Roman concrete or ancient mortar, helps us figure out what they were made of and why they've lasted so long. This tells us how they made these materials and what made them special. But sometimes, the best way to understand how something was done is to actually try and do it yourself. This is called experimental archaeology. Teams try to copy ancient building methods using only the kinds of tools and materials they believe were available back then. For example, experiments have tested different ways ancient people might have moved massive stone blocks for pyramids, using rollers, dragging sledges over specially prepared tracks, or coordinating huge teams of people pulling ropes. Researchers also build replicas of ancient cranes and levers based on old descriptions to see what they could actually lift. Modern teams have even recreated Roman concrete, confirming its amazing properties, like how it could set underwater and even heal small cracks over time. Others run small experiments, trying to copy the precise way the Inca cut and fitted stones, testing different ways of pounding and grinding the rock. Of course, figuring all this out isn't easy. Often, the evidence is limited or unclear. Ancient texts can be hard to translate or interpret correctly, and old pictures might be artistic representations, not exact technical drawings. Plus, it's incredibly difficult to replicate the sheer number of workers and the level of organization needed for some of those enormous projects. Despite these challenges, the effort gives us amazing insights. We gain a much deeper respect for the sophisticated understanding of materials, physics, and planning that ancient cultures possessed. Studying their successes, and sometimes their failures, like collapsed buildings or projects left unfinished, shows us a long history of people learning, adapting, and solving problems. Understanding ancient engineering isn't just about looking back. It reminds us of what humans are capable of. Some ancient ideas, like ways to keep buildings cool without air conditioning or the recipe for super durable concrete, are even inspiring sustainable solutions today. By carefully reconstructing these old techniques, we don't just learn about history. We connect with the incredible spirit of human innovation that shaped the world we live in.